What I'd like to do today is show you how to make a parallel circuit, and we'll compare that to our series circuit that we created the other day. So let's go to New Circuit, or Create New Circuit, and we're going to get out that same battery that we used the other day, the 9-volt battery. So we're going to take that 9-volt battery, I want to rotate that around, and if we take a look at that, it's got a red lead and a negative lead, or a black lead, which is negative, and red is positive. So the colors tell us that one side is positive and one side is negative. Red tells us that is positive and black tells us that's negative. When we wire a parallel circuit, we want to click all the positive sides together and all the negative sides together on the components. So on an LED, if we bring that out, an LED has a cathode and an anode, so it has to be wired in a certain way, otherwise the LED won't work. And the anode's the positive and the cathode's the negative. We're not going to be using LEDs today. We're going to be using a different component that we're going to have to search for. So I'm going to go into my search bar here and I'm going to type in light. And if I slide down under other components, it will have a light bulb in there. So I'm going to bring out 3 light bulbs. So I'm going to be using 3 light bulbs today. Okay, and I'm going to go back to my basic components. And I'm going to grab myself a switch. And the first thing I'm going to do is I am going to wire the positive lead. Okay, and that's positive, so I want to make that red. And then what I'm going to do is I'm going to rotate this light bulb. So I'm going to take this light bulb and I'm going to rotate it. I'm going to slide it right in here, and then I'm going to go to my next light bulb. I'm going to rotate it. Going to slide that in there, and I'm going to, if you make a mistake like I just did, just keep clicking around, and then I'm going to go to the other one. I'm going to get them all kind of lined up to make them neat. And we're going to say that terminal number 1 is going to be the positive. On these style light bulbs, it doesn't matter negative or positive, but it's going to help us when we do parallel and series, and we're going to do parallel. So what I'm going to do is I'm going to take this terminal, I'm going to come up here and just neatly bring it over, and I'm going to click it to the other side of the switch, and I'm going to make that red because we're calling that the positive side. I'm going to do the same thing with this terminal. I'm going to go back up there and make sure I hook onto the spot. You got to wait for it to give you this where it says common there. If it doesn't say common and you click, it's not really connecting it. So that looks good. And I need to make that red as well. And I'm coming over and doing my last one. I'm going to make that red as well. So if we look at what we got here, we have positive going into the switch, and then we've got it coming out the switch on 3 different paths. 1, 2, 3. So now what we got to do is we got to take the negative side, and we're going to go over here to the negative side of the battery, which is the black side. And I'm going to make that wire black. I'm going to do the same thing with my next wire. Make sure you see negative before you click it so you know it's going to connect. And then I'm going to come here and do the last one. Right there. I had to move in and zoom in to get that to show. And there. So now if I hit simulate, all my light bulbs come on. So what I want to show you, what's neat about a parallel circuit versus series circuit, is that since each light bulb has its own path back to the source, if one of the light bulbs goes out, the other ones will continue to work. So if we follow the path here, let me zoom out a little bit and try to make that a little bit neater for us. The path electricity is flowing through the switch, coming down through the light bulb, so it's got its own path. The second light bulb, let me zoom back out a little bit. Electricity goes through, it's got its own path, goes back to the battery. The third light bulb got its own path, going through the light bulb and back to the battery. So if I stop this simulation and I take this one light bulb and I just delete it, and I run the simulation, the light bulbs will still work. So now we have our parallel circuit built. Let's do a little metering on it. So what we're going to do is we're going to get out the digital multimeter. We're going to set it to volts. We're going to turn on the simulation, and we're going to see what kind of voltage is going across each light bulb. Remember, when we checked the series one out, all the light bulbs added up to equal the voltage of the battery pack. So remember, we had the resistor in there, and the resistor consumed 3 volts, and the 3 light bulbs each consumed 2 volts or 1.99 volts, and it added up to 9 volts. Let's see what happens here with a parallel circuit. So I'm going to slide down and I'm going to grab my meter. I'm going to put that up there, and I'm going to make sure I'm on voltage. Okay. Remember, I got my positive and negative lead up there, so I got to hook those to the right spots. Okay, I'm going to start my simulation. I'm going to take the positive lead. Okay, and see how it's not letting me grab it right now? It's because I cannot hook the wires up while the simulation's running. So I'm going to hit stop. I'm going to grab my lead now, positive. I'm going down to the positive side there. And let's make that red. And I'm going to go negative to the negative side over there and make that one black. And let's hit start. And I'm getting 8.23 volts. Okay, so I'm not getting quite 9 volts, but I'm getting close to that in the first light bulb. So let's go check the second light bulb. Let's stop our simulation. We're going to just click on these wires and hit delete real quick, and then we're going to redraw them down to the next light bulb. Okay, I'm going to make that one red. I'm going to make this guy go down there. I'm going to color that one black because that's negative. I'm going to start my simulation, and I'm getting 8.23 volts again, the same as what I got here. So the question is why are these two the same? And let's just go to the third one and see what the third one's going to do for us. See if it's going to be the same as well. So again, I'm just going to connect my wires, make them the right colors. Let's start my simulation. I get the exact same thing. So what that's telling me is in a parallel circuit, the voltage across each component or each light bulb is going to be the same. And it's very, very close to the battery voltage. So we're losing a little bit of voltage through the wire or through the switch. Something's consuming a little bit through resistance, but each component gets the same. That is not what happens in a series circuit. In a series circuit, depending on what the component needs, we're going to add all those together, they will equal 9 volts. In a parallel circuit, that's not the way it works. A parallel circuit, all the components get the same voltage. So, if this was Christmas lights, and one of the Christmas lights went out on my Christmas tree, all the other Christmas lights would stay on. If it was a series circuit, and one of the light bulbs went out, all the lights on the Christmas tree will go out. So what do you think your Christmas tree is wired? Is it wired in series or is it wired in parallel?